Hi, my name is Tom Moore, and I'm a .NET Developer Advocate with AWS. Welcome to my session on building secure lab environments with CDK and C#. Now, I've been around AWS for a little over 6 years now. For the majority of that time, I was a solutions architect, so I helped give enterprise customers advice on everything from migrating infrastructure to the cloud, building cloud-native solutions, and how to implement security controls inside of AWS for their common tasks. Here's the agenda for this session. First, I'm going to outline some of the common mistakes that are made when creating lab environments. Now, I'm particularly focused on lab environments that are designed to be spun up and torn down for specific use cases or learning objectives. We'll cover some of the ways that this can cause issues. We'll dive into some of the practical solutions that can be used to overcome these issues. And I stress the idea of practical. We're looking for easy to automate solutions that enhance the security of your environment without imposing undue restrictions that make it difficult to use the environment. We'll then dive into some CDK code and see how we can use C# and CDK to prevent these issues from happening. We'll have a demo of all of this in action, and then finally we'll look at where you can get the code that we're using here today so that you don't have to try to copy the code off of the slides. So let's have a quick look at some of these common mistakes that get made. This is the way lab environments typically get set up. Now, we do this at AWS when we're creating learning environments for immersion days when we go out to see customers, or events like reInvent where we might have hands-on learning available. Our customers and partners also do very similar things as well when they have some form of canned lab learning scenarios. The process starts off with a CloudFormation template, which defines the lab environment. Now, I say CloudFormation because in the end, if you are creating the template in something like CDK, or even SAM, or Chalice, it all bakes down to CloudFormation in the end. So it doesn't matter what tool you're using, what gets deployed into your AWS account is going to be CloudFormation. Now, that CloudFormation template contains all the resources that are necessary to set up the environment and get ready to go. We then use that to fire off multiple lab environments. Each of the lab environments is exactly the same because that's what we need in order to create a learning environment for you to use. Plus, if we're learning about something like, say, connecting your .NET application to an Amazon Aurora database, we really don't want to waste half an hour creating the Aurora database every single time that we're going to do this learning. We want to be able to dive right in and get to what we're trying to accomplish. Now, is there a time and a place for learning how to set up an Aurora database? Absolutely. But do we want to spend the time to do this every time we're learning something that involves Aurora? Probably not. So, have you ever had a situation like this? You have an instructor in front of you, or these days, maybe on the other side of a video conference. And the instructor is going to go through some a lab exercise with you and teach you a whole bunch of things. They go through the learning objectives and they talk about what they're going to teach you for the day. And then the instructor says, the password for this environment is password 1. Maybe they offer to write it down on a whiteboard. Maybe they hand out sticky notes or pieces of paper that are lab guides, for example, with the password written on it. Maybe they put the password into a chat window of the video conference software. So now we have problem number 1. The same password is used across all of these environments. Everyone who is sitting at that training session now knows the password to every environment, as well as anybody that happened to be walking past the room when it was announced. Now, let's say I'm running a lab for somebody, and they have, say, 20 people. I've probably spun up a few extra lab environments as well, just in case somebody walks in at the last minute and says they want to participate. Or, if something goes wrong in one particular lab environment isn't quite up to scratch, I want to have a couple of extras. So that's quite possibly a lot of compromised environments that are out there, all with the same username and passwords in order to gain access to the resources. So how about this situation? You're working in a lab environment. You're all set to dive in and do something. The lab environment is done on a web page, for example. Now you read through the introductory pages, you understand the learning objectives, what you're going to be doing, how long it's going to take, and then you see an instruction that looks like this. The password for the lab environment is password 1. Now we have problem number 2. We've just announced this password to the entire world. We have problem number 3. That password can never change. And we have problem number 4. We have absolutely no control over who can get access to this password because it's out there on the internet. Now with infrastructure as code, we're encouraging the reuse of common constructs. So my lab environment that has now been built with this idea of a static password, now maybe that is used as the base for another lab or another training system and another. So now this bad password that has been exposed on the internet is now across multiple lab environments. So we've pretty much violated every security principle ever created as far as passwords are concerned in one fell swoop. We've reused passwords. We've used passwords that don't change. We've told everybody the passwords. We've written them down on a sticky note or a piece of paper. We've definitely not disposed of those bits of paper properly because they probably got left out sticking on the side of a desk or fallen down on the floor. And we put all of this available on the internet. The situation really can't get much worse, can it? Right? Well, it turns out it does get worse. So one shortcut that's often taken for lab environments is allowing RDP access to the instances that are created from anywhere on the internet. Now this means that you have a Windows machine accessible from anywhere on the internet with a publicly known password that we've already exposed. So now we have problem number 5, security groups that are left open for convenience. Now, people generally do this with the best of intentions. There's no way of knowing what user's IP address is going to be at the time that the lab is run. They want to make it convenient for the end users, so they make a rule like this allowing open RDP access. However, all of that convenience comes at a cost. So you may be thinking, well, what's the worst thing that can happen if somebody gets a hold of a single machine, right? Well, it turns out that we have problem number 6, that oftentimes these instances that are set up in lab environments have IAM roles that are excessively permissive. Take, for example, this snapshot here, where we've given the lab instances administrative access. Now, to be fair, this isn't specific to lab environments. We often see roles that are configured with excessive permissions, and this is something that you should be extremely cautious of. However, this, combined with the issues we've already covered, is a recipe for disaster, as the account can now do anything inside of your AWS account. So it's all well and good to complain about things and tell you what not to do, but what we really want to do is have some practical solutions to fix these issues. And again, when I say practical, I want the solutions to work, but I don't want a situation where the antidote is worse than the poison. We don't want to create an environment where these lab environments you're spinning up aren't usable for people to learn from. And because we're all developers here, and because my programming language of choice is C#, I want to do all of this in CDK using C#. So here's a list of all the things we need to fix that aligns with the things that we've already identified. We want to use unique passwords across all of our environments every time they're spun up. We want the user to be able to get access to the password without having to announce it to the world or resort to things like sticky notes. We want to make sure the passwords can change, and in fact the passwords do change every time the environment is set up. We want to be able to control access to those passwords. We want to be able to lock down the security groups, but we also want to be able to access the machines through RDP so we can actually use them to perform the lab materials and the learning objectives that we want to do. And we want to easily make sure that each instance has permissions that correspond to just the permissions that the instance needs. The first challenge we need to address in this solution is to fix the issue of using static passwords. Thankfully, AWS provides a simple method to achieve this with the AWS Secrets Manager, used in conjunction with managed Microsoft Active Directory. Now, Secrets Manager can, as part of a CloudFormation template, generate a random password. This achieves the ability to have different passwords for every environment every time, because the password is generated when CloudFormation runs the template. We can then set up a managed Microsoft Active Directory using that random password as the administrative password. Finally, we can use this managed Active Directory in conjunction with Systems Manager in an automation document to automatically join our EC2 instances to our managed Active Directory as part of their creation without ever having to log into the instances. So we can see here all the code that's necessary to create our Secrets Manager entry with that random data for the password. Now you can fill in some parameters about how you want that secret to be created. You can see here there's an option to exclude certain characters from your password and an option to set your password length. Now, as far as access is concerned, because we had concerns about being able to have some control over how accessible passwords were, access to the Secrets Manager entry is governed by the IAM policies, so you can control who has permissions to actually decrypt this password. So already, a couple of our concerns are taken care of directly with just this one chunk of code. So next we want to be able to create the managed Active Directory using that random password so that we can have the same access control across all of the EC2 instances that are created for this environment. So here we have the code to create a managed Active Directory and feed the password in directly from Secrets Manager. It's totally hands-off, nothing to do from our side, and we have Active Directory ready to go with a random password. You can see here that line, and what we're doing is saying for the password, we're going to resolve the Secrets Manager secret. We give it the name, and we're retrieving the password. Now all the rest of these details, so the name, the short name, the VPC settings, and the addition, are standard code for creating the managed Microsoft Active Directory as part of a CDK project. One thing to be very aware of, we do want to add this little dependency node here to make sure that we don't start creating the managed Microsoft Active Directory until such time as the admin secret that we created in the previous code snippet has been done. So this forces this section of the CDK project to wait until the other part has been completed. Otherwise, we'd have problems because resolving this secret would fail. Finally, since we already have Active Directory set up and we need an EC2 instance for our lab, all we have to do is spin up an EC2 instance and have that connect to Active Directory. Now, we don't want to have to log into each instance and manually join that Windows virtual machine to our domain, so we can take advantage of the Systems Manager service and the associations automations to automatically join this instance to manage Active Directory. And you can see there, you can see here as part of the creation for this EC2 instance, I've added SSM associations and I've provided the document name. So now the one bit that's missing and required to work, and that's the creation of an SSM automation document. Now, I haven't outlined it in the slides, but it is available in the sample code that we'll have at the end of the session. So, with just a few snippets of CDK code, we've actually taken care of quite a few of the issues on our list. We're no longer using the same password across all the environments because we have a random password generated every time. We don't have to provide the passwords out on the internet or use any form of documentation or sticky notes or even say the password out loud, the passwords are changing with every single time the environment is spun up, and we have control because the people who can access the password are governed by the IAM policies of the AWS account that we're creating the resources in. The next issue we want to address is the idea of these open security groups. Now, a very common mistake people make, especially with these lab environments, is to allow RDP traffic, so traffic on port 3389, to be accessible from the internet with a 0.0.0.0/0 access rule, as you can see here. With this rule in place, once somebody discovers that a machine is up and running on the internet, so probably within 5 minutes after launching, if you're lucky, they can start brute forcing attacks against the machine. Once again, Systems Manager provides us with an easy way around this. There are a couple requirements though. First, you have to have the Systems Manager agent installed on the machine. The good news is, if you have an Amazon provided AMI, or you've started from an AMI that was originally created from an Amazon provided AMI, this is already done for you. There's nothing left to do. There's nothing for you to do here. The agent already is pre-installed. Now, second, you have to have an IAM role attached to the instance that has the Amazon SSM Managed Instance Core policy attached, as you can see here. This policy, attached by way of a role, gives the EC2 instance permissions that it needs in order to talk to the SSM service. Third, the instance has to have networkable, addressable access to the Systems Manager service. So if you have outbound internet access, you're good. If you don't have outbound internet access, then we need to work on the ways that you can gain access. But we won't cover those here. That's a more advanced security topic. Fixing our security groups is pretty easy. Since we're doing this in code, we can write once and we can use the same construct many times. You can see here, I'm creating a security group and I'm only adding a single ingress rule, which is allowing traffic in from the VPC. So my VPC I've defined with a 10.0.0.0 address space. Now, to be honest, we can and probably should be even more selective here with our rules, but this is only going to allow traffic from the VPC, not any traffic from outside of the VPC. So it's better than allowing internet access on the RDP port and allowing us to communicate with the machine that way. So this does fix the issue of having the wide open security group allowing RDP from the internet. But of course, we still need that RDP access. So we've taken care of blocking the access through the security rules, but we haven't quite got enough to enable RDP access into that machine yet. So fixing the security group addressed half of the issue, not allowing RDP access from the world. However, we still need to get access from the RDP session from our local machines for authorized people. In order to do that, we'll create a role that allows the instance to connect to the Systems Manager service. Now here's the code. So we're creating a role. We're saying who it can be assumed by, so EC2, because we're attaching it to the EC2 instances, and we're giving it a role name. We're just going to call it lab role. That's fine. And then we're going to attach the policies we need. So we're adding the managed policy of Amazon SSM Managed Instance Core. This will allow us to manage the instance and give us some functionality that we're going to see later. And we're giving it the ability to access directory services so that this machine can, in fact, join itself to the domain through the automation document that we created earlier. Now, one step that's commonly missed A role is a set of permissions that can be attached to the instance. However, we need an EC2 instance profile to make the connection between the role and the instance. So here we have the code to create the required profile. So we're creating the profile here, and we're providing it with the name of the profile and the roles that are attaching it to. Okay, so I've jumped back to the code that where we were creating that jump box instance. And we're not creating two. This is the same code. We're just revisiting one part here. Here, as part of that creation, we are specifying the IAM instance profile that we created in the previous step, as well as the association here. So these two bits combined is going to allow us to create an EC2 instance. It will have the required permissions, and it will automatically join itself to the domain that we created. Now, once that instance is created, you'll be able to go into Systems Manager, select the Fleet Manager portion of that service, and you'll be able to connect. And you'll get an option here that says User Credentials. This is appropriate because we're trying to log in with a domain account, or you could use it if you had a key pair. Then we want to pass the username. So you can see here we're passing in the details. Corp being the domain that we created, and admin being the high privileged account that's created for us. And then the password is the randomly created password. And then we'll be able to hit the connect button. And then after the connection actually occurs, you're going to get a RDP session right in the AWS console that you can use to connect and interact with the machine. You can see here in this case, I was actually able to log in. I ran Who Am I? And you can see I was logged in as corp/admin, the administrative user I was logging in as. So from here, I would be able to do the typical actions that I would do from any RDP session. Now, of course, you don't want to just take my word for it with some slides. Let's actually jump in and see a demo of this in action. Okay, so here we are inside of the AWS console. And I have already deployed the CDK project that we were working on in the slides. Now, just to show you here, if we go into CloudFormation, you can see, here we go, EDD. This is the stack that I created and deployed as part of the setup for that, for this demo. And you'll be able to see there's a whole bunch of resources that were created as part of that process. So there's a Microsoft Active Directory that I created as part of that. There are SSM parameters, and so what I've done is a bunch of the data that came out of the stack, I've stored that in parameters so it can be used later. Here's the lab role that was created. So I've created this as part of a lab role as part of the project. That has the permissions attached to it that allowed us to complete various items. Here is the association document, and I'll show you that in the code in a few minutes as well. So from here, now the goal, obviously, as we were working through the slides, is I want to be able to log into that instance using RDP. Now, we'll have a look here at EC2. And if I look at my running instances, You can see here EC2 jump. Now that's the instance that I created as part of the CDK project. If I look here under security and I look at my inbound rules, you can see that all I have is this security rule that allows RDP access in from the actual VPC, which we saw in the code snippets that I was showing before. So if I was to try to RDP into this instance using its public DNS address, I would never be able to actually connect to it. RDP would just time out. So what I can do here is, let's go up here and look up Secrets Manager. Oops. You can see here I've got the managed Microsoft Active Directory admin secret, which is the password that was created. Now if I come down here, the secret value, I've got this button here that I can click to retrieve the secret. And now this is all governed by my IAM permissions. Obviously I'm an administrator of my own account here. So I've got this password here, I can copy it. And what I'm going to do is I'm going to go back to Systems Manager. And now I'm going to scroll down here. Over here under Node Management, there's Fleet Manager. Now, Fleet Manager provides us with this functionality that allows us to connect into the instances, as well as some other functionality that's available. So I get here, I'll get the nodes that I have in my account. So Manage Nodes. This is that EC2 jump box, as you can see here, and the platform type is Windows. Now, one of the things I can do is I'm going to go over here under Node Actions, and I'm going to say Connect with Remote Desktop. Now, we saw this a little bit in the slides. I've got two options here. I can connect with user credentials or a key pair. So I want to connect with user credentials. So corp is my domain /admin. Admin is the user that is created automatically with the Microsoft Active Directory, and I'm going to paste in the password that I got from Secrets Manager. Now I'm going to hit connect, and I'm going to say not save those details here. And you can see I'm actually into the machine. I can type and access commands. Now, obviously using this small window isn't that great if I'm doing a lot of commands, so I can actually click the button and get a full size RDP window. And I can launch, I can do everything I would expect from an RDP session. Doing things like copy and paste, because I am actually leveraging RDP. So I have full access to that system, and I can do everything I would need to do in the event that I'm doing some form of learning activity actually on this machine. And as you can see from me using it here, it's actually fairly responsive through the desktop. And of course, accessing anything here through Internet Explorer, which is obviously the very old browser, is not the best of experiences. Now, another thing that you can do, another way that you can use Fleet Manager to gain access, and I'm going to end the session here. If I'm back in Fleet Manager, the other thing that I can do is I can start a terminal session, again, directly through Fleet Manager. And this is going to allow me to do PowerShell commands directly within inside of the machine. So once again, I don't have any ports open to the machine. I don't have any port forwarding required into the machine, but I now have a PowerShell directly into that instance. And if I was to check this host name, it would match up to what's actually connected. I can see here a 10.0.0 address that is allocated inside of the VPC. So I've got access to be able to do all kinds of management functions, both through a terminal session like this into PowerShell or into RDP. That was one last thing to have a look at before we jump back into the slides. You can see here we're actually inside of Visual Studio. Now this is a CDK project that was used to deploy that infrastructure. So we'll just have a quick look here. I start off here with a CloudFormation parameter, and what this is going to do, this is going to go out and automatically grab the current, in this case Windows Server 2019 AMI for you. So you don't have to know what the current version is and update constantly. This will grab that for you automatically. You can see here the admin secret. So this is creating that random password. We covered that a little bit in the slides. We create a VPC, so that's not terribly interesting for the purposes of this code. We're creating a role. So in this case, this has a couple more permissions than what was in the slides. But again, we're creating a role that allows permissions for that instance to exert inside of my AWS account. The profile, which connects the role and allows that to be attached to the instance. And you can see here is that that creation for the Microsoft Active Directory, the managed Active Directory, the values we're passing in. And here is the statement that allows us to grab that password directly from Secrets Manager. So we're grabbing that random password and using it. As I mentioned previously, make sure you have a depend on clause added for that admin secret. So that's the secret we're creating here. We want to make sure that this completes before we try to complete the Active Directory. Now here I've got some code. It's a bunch of dictionary commands. I didn't have these in the slides, but this is what creates that document, that automation document that we're going to run, and allows us to automatically join the instance to the to the domain we're creating. So we're going to pass in the directory ID. We're going to create the document. It's going to have the directory ID. It's going to have the DNS IP addresses for the Active Directory. It's going to pass in the details of the actual directory. So corp.local is the fully qualified domain name that we used to create that instance. And then we're just going to pass that in. We create this document and we simply pass in the content, which is that set of dictionary entries here. We've got the security group that we've created. In this case, we've got a public and a private. so that we could vary the rules if we need to. And then we create the jump box. So this has got a few more properties than what was in the slides here. But again, we're creating an EC2 instance, passing an instance type. We're passing in the AMI, so that image ID is the AMI that we retrieved. The role, the security group. We're creating that association with the SSM document that we created earlier, passing in the subnets and setting the tags for the name. And then the rest of this here, we're just creating string parameters. These go into parameter store, and they allow us to see some of the values that we might want to save for later. It also makes it so that you can retrieve those values in a later CloudFormation. So if I had another CloudFormation document or another CDK project that I wanted to add on top of this, and maybe I need to know the instance role because I want to use it, or I want the name of the document that's being used to automatically join my instance to the domain, I have all of these available. So, and you can check those out in your account after you've run the template. So let's just recap as to where we are. We had a whole bunch of issues that we wanted to address at the beginning of this session. However, most of these are already done. As we saw, we've taken care of the password problem. We've added control. We have random passwords. We fixed the security groups. There's now no traffic allowed into this instance from the internet. We've eliminated the risk of RDP from the world, and we've removed the overly permissive access roles and used access roles that are targeted to the permissions this instance needs. And we still have that RDP access available from the world. So we're able to use this fully featured. We haven't added any work for the users to do, but we fixed all of these problems. Now, I promised you at the beginning of this session we'd be able to provide the code so that you can actually get the snippets and use it in an environment if you want to sort of copy and paste out of the sample that's done. And the code is available here. It's github.com/basement programmer, and you're looking for the CDK.NET Securing Lab Environments project. It's available up there, and you can go ahead and grab it. So thank you for attending this session and watching. Hopefully you found it useful. My name is Tom Moore. You can email me at moretom@amazon.com, and you can follow me on Twitter at Basement Programmer.